Hi everybody, welcome to my talk here about going serverless with a Spring Boot 3. My name is Timo Salm and I'm a pre-sales specialist for developer experience at VMware with a main focus on our internal developer platforms running on Kubernetes, like for example Azure Spring Apps Enterprise, which we jointly built together with Microsoft, and our commercial Spring products. Today I will first talk a little bit about what serverless is before we are actually running a software on a serverless runtime. And then we will have a look how to run serverless applications with Spring Boot. So what's serverless? Serverless at the end doesn't mean that there are no servers, it just means that you don't have to care about them. And you can group serverless into two specific areas. The first one is backend as a service, where you're replacing server-side self-managed components with off-the-shelf services. Examples are, for example, Okta or Auth0, where you don't have to care about managing the authorization server or implementing it, and instead Okta or Auth0 is doing that for you. Another group or area is function as a service, a new way of building applications as smaller functions. And the idea is the same, so you don't have to care about the underlying infrastructure, hosts, or processes. An example for a function as a service experience you're aware of on runtime is, for example, AWS Lambda. The key for both is that you can really focus on business value and don't have to care about stuff your company, for example, doesn't get too much value out of. So why should we use serverless? And it's always, if you are having a look at the new technology, you should ask yourself about the why, the value it provides. And the biggest value of serverless is really the shortened lead time. So because of the fact that you don't have to manage, install specific infrastructure components and the server hosts, you can focus on other stuff, and also it's a lot faster to get started. Another aspect of serverless is really the increased flexibility of scaling. So as you maybe know from AWS Lambda, you don't have to care about the scale. Based on the demand, it will scale up or down or to zero. And it's also something where you can reduce a lot of cost, because if there is no application running, you don't have to pay for it in such serverless models. It's also like you can reduce a lot of cost regarding manpower you don't need anymore, or you can use for other stuff that's maybe providing more business value. And you have reduced risk because you don't have to manage the stuff. Someone else has to care about that. For example, AWS Lambda is up and running. Serverless also has a lot of drawbacks and limitations, and here are just some of them. So it's like, for example, the unpredictable cost. So if you configure AWS Lambda in the wrong way, it's consuming a lot of resources, and with that you pay a lot of money to AWS Lambda. Another problem we are trying to resolve later with our Spring Boot applications is that spinning up machines takes time. So if you do horizontal scaling, which is usual at serverless platforms, it's like it takes some time the application is available. And for a Spring Boot application, for example, several seconds. And if you scale and don't have the required resources available, or the applications running the instances to handle the request, your clients can run into timeouts, and you also have to handle those situations, because it's something that commonly happens if you create modern applications. Also, vendor lock-in is a problem if you're using, for example, AWS Lambda, as long as you don't use an open source solution, which I will introduce in a minute, called, for example, Knative. You have a lot of loss over control, because if it's abstracted away from you and someone else is caring about you, you are not able to, for example, care about the security, etc. You'd have to, in a way, trust the organization you're buying a solution from. There's a lot more as that, but because of the limited time, I don't want to talk about any of the drawbacks. But as that, always keep in mind, if you're choosing a new technology, ask yourself about the why, what's the value you provide. Is, for example, your application even capable of using those benefits of a serverless application? So is it, for example, stateless? If not, maybe it's not the right solution. If you have a serverless runtime that auto-scales, based then also on the drawbacks, make the decision whether it's worth the try or not. So let's talk about Knative. I already talked a lot about AWS Lambda. It's, I would say, one of the most popular serverless runtimes. Knative, on the other hand, is an open source project running on any Kubernetes, so on the public cloud and also on premises. And with that, you have a serverless runtime everywhere. A big benefit of Knative project itself, or specific that serving component, is that you can run any container on it. So you don't have to package it in a specific way, like for example AWS Lambda. Yes, AWS Lambda is also adding container support, but again, it's like any container can run on Knative, and with that you can even, if you want to, run a serverless stateful application on it, and for example limit the horizontal scaling to one instance. At the end, it doesn't provide so much value than if you have a stateless application. At the end, Knative consists of 3 different components. The first one is serving, I already talked about. So serverless runtime on Kubernetes, which provides a higher abstraction, auto-scaling capabilities, revisions, so you can fall back to a previous version, can do canary blue-green deployment, for example. Then we have eventing, which really is at the end managing you or providing a high abstraction for event-driven architecture. So triggers for events, a broker abstraction, so that you don't have to care about the underlying RabbitMQ or Kafka, for example, that is transporting the messages between your applications, and then also specific sources, like for example, on AWS, S3 or something like that, where you want with your functions save your information in. A newer addition is the functions experience for Knative. At the end, it's really like helping developers create a function as a service architecture. So at the end, smaller functions that are focusing on a specific aspect. And if you have, for example, eventing, you can connect them via events, and they can also then, if they are running on serving, auto scale based on the demand. Another component, not part anymore of Knative, is how's it called? A project by Google to also at the end create container images in a cluster based out of Docker files. Canico is the name, but as I said, so it's not part anymore of Knative. Today we'll really focus on serving, so for sure I could also use the function experience to show you what I want to show, but it's not relevant for our topic here, so we'll really focus on the Knative serving as a higher abstraction and serverless runtime on Kubernetes. And for that, let's first try out our first Spring Boot application on our Knative serverless runtime. For that, the first thing I have to do is I have to package it in a container. And as you know, so what developers usually do is they create a Docker file. You go to Google, search for Spring Boot Docker file, you will find it. It has 4 lines, and that's it. It works, but it's in no way secure and not production ready. And a more production-ready Docker file would look like, okay, choosing a specific Java runtime environment, doing multi-stage build, doing layer jars. So a lot of more expertise is required to build such a Docker file. And to solve that problem, Pivotal and Heroku created that cloud-native build pack standard. And the idea is that developers don't have to care about how the container image look like. So with best practices in mind, the build pack is able to detect whether, for example, the build tool is Maven in the source code. It's able to detect, okay, which JRE version is required or has to be contributed to run the application, and other stuff like, for example, CA certificates, etc. And this build pack, which is at the end also, or build packs that are really modular, they will then, based on the detection, know what to, at the end, provide to the container image, build a container image, and developers don't have to care about it, and it's secured. And this is what we want to do now, and the support for cloud-native build packs was directly added into Spring Boot with a version 2.3. So it's like if you run, as you can see here, the build image command, or then what Spring Boot will do is download the build pack, a stack, so a base image, and build a container for you without defining a Docker file. We will do this now. So one thing I want to add here is that I'm running it on a Unix environment in Kubernetes, because of the fact that those build packs currently don't support ARM processors, and because of the fact that I have an ARM processor, it doesn't work on my machine. But hopefully we will contribute the support as soon as possible, and also from a colleague of mine, so Deshaun, he created one that you can also give it a try if you want to run it on your computer and you have a M2 or M1 Mac. So at the end, what's doing now is really, okay, it's a Maven project in this case. It detects that, it builds the application with a Maven package command because it knows how to do that. And then it's, after it has downloaded all the builders, so they have some size at the end, it will package that together to a container image. And I could also directly, via the ---- publish argument, push it to a container registry. In this case, I'm doing it manually. So this can take some seconds, but you can see it's already adding the layers. It's saving it to my container registry, or it's locally. And now I can run Docker images. I can see this is the image. I can see the size and the digits of it. And now I want to push it to my container registry, which takes some seconds. But as I said, because it's running in a Kubernetes cluster and on AWS, hopefully not that long. And the next thing I want to do is really running on Knative. And to make it a little bit easier for you to see what's happening, instead of creating a YAML file, which is also really basic in this case, but to have a nice experience, there's a KN CLI, so Knative CLI, that really helps you if you want to give it a try on Kubernetes as easy as possible. So the only thing I define is a name for the resource, the Kubernetes resource, and the image. And then the Knative running in my Kubernetes cluster is taking care of the rest. And what it does is really like, it creates that, it's called a Knative service that consists of a configuration, and the configuration will be used for specific revisions. So if I update something in my resource for Knative, it will create a new configuration, a new revision, so that I can fall back. It will also create auto-generator ingress, etc. So any object that you need to access your application from the outside. And add also those auto-scaling capabilities, as I mentioned. You can see it also automatically, because it's configured in that Knative configuration, HTTPS for me, so TLS by default. It can also auto-generate certificates. So a lot of burden at the end abstracted away from the developers. What I will do now is just call it for a second, and it works. And the next thing I want to do is really want to show you the auto-scaling capabilities, because this is why at the end, we are running the application on a serverless runtime to also have those auto-scaling and scale to zero capabilities to at the end reduce costs and also handle demand if there's, for example, a new PlayStation launch or whatever, that our servers don't go down, and we have horizontal scaling capabilities to handle the traffic. First, let's have a look at the startup time of our application. As you can see, it's around 4 seconds. So please keep that in mind, that we can later see how we can improve that in a way and whether we can improve it. For the auto-scaling, let's have a look at the pods. You can see currently there's one instance running. If we wait a little bit, it will scale down to 0 because it's configured, but you can also configure in Knative globally or for your application whether you want to have scale to 0 or not, and also the maximum scale, so hundreds or thousands of containers. What we want to do now is really simulate some traffic, and we're using the Hey tool for it. If you want to try that out on your computer, because of all the requests Hey is sending, usually it's like that your computer is not able to handle that. So just for information, so maybe create a jump box, for example, on AWS, etc., where you have the capabilities to really run so many commands, because with that command it will run 1,000 requests per second. So I have to interrupt it as soon as possible. But you can also see that it already started to create containers based on the traffic, and but it takes some time to start them because of the fact that even our application started within 4 seconds, and you can assume it's a Hello World application. If you have a larger application, maybe 10 seconds, 20 seconds, and with that, as I said, the clients will maybe run out of time. And another thing we want to look at, so we already had a startup time, 4 seconds, is the memory consumption or CPU consumption. And if we run that command, we can see, so here are all the different containers, and usually it's about 175, so around 200 megabyte of RAM and 2 CPUs for the user container. So this is where the application's running, and the kubeproxy is a component of Knative. Okay, so at the end, our application was able to run on it. As that, it's like you can run any container image on top of Kubernetes, on top of Knative, but it's like not the experience we are looking for, because we want to have really fast startup times to be able to handle the traffic and in a way to mitigate the problem of timeouts at our client side. And also, if you have a lot of thousands of containers that are scaling, maybe it would make sense to reduce the resources a little bit to save also costs. And yeah, this is what we want to see, whether it's possible to do that with our Spring Boot application running on the JVM to, at the end, save money and also make our customers happy. And for that, let's first have a look how our application is in a way compiled and then runs on a virtual machine. So it's like our Java classes or source code will be compiled into a bytecode, packaged in a jar archive, and this will be then run on a JVM. And there is a bytecode interpreter that at the end executes our application. And because of the fact that it's always slower than a native running code native, there's also a JIT compiler involved, which at the end adds some startup time and also resource consumption, which for specific paths that are executed frequently, it will compile it to a native code, the JIT compiler, and with that we also get those performance benefits on a JVM. But as said, the problem is the improved startup times, improved memory consumption also because of that, or CPU resource consumption in general. If we have a look at really this native compilation with ahead of time, the idea is that instead of using or creating the bytecode, packaging it on a jar file, and then running it, the bytecode, or interpreting it via an interpreter on the JVM, the idea is that we create ahead of time a native executable. For that, for sure, we have to know every source code part that will be used then on runtime. That has to, at the end, the compiler has to be aware before the application runs. And then this native image will run on our operating system at the end. The problem with that is also that it's specific to an operating system. So it's not possible to compile it on Unix and then running on something else. And so let's have a closer look what native images are at the end, so that are built with ahead of time compilation. At the end, it's really a standalone executable of our Java application. It includes everything to run our application. So also, for example, as it doesn't run on a JVM, it includes a so-called substrate VM. So all the common parts that are required, even if it's not running on a JVM for the application, it's specific to a machine architecture and the operating system. And the big benefit is it requires a few resources because it's not running on a JVM. And also doesn't have to run the just-in-time compilation. Currently, as far as I know, or still up to date, the only solution to create those native images or compile them is GraalVM. But in the future, there will be probably more, like for example, Project Layton. And the basic idea for GraalVM is, in addition to that native image compilation support, is to have one virtual machine to run a variety of languages. So any JVM language, where for sure also Java belongs to. And additionally, it has a so-called truffle engine to also run languages like JavaScript, Ruby, or Python. And the idea is that you can run even those languages in the same application. So you could, for example, create an application where you run most of the parts in Java and then have a specific functionality that is using machine learning or whatever and run that in Python in one application. So that's possible with a truffle engine. GraalVM is relatively new, so it's getting more mature every month or year. But we will now have a closer look what it provides, whether it provides all those benefits we want to achieve for our serverless runtime. And for that, let's run our first native image. So we will get back to our workshop. And let's start with this really basic application. And because of the fact that our session here is only 45 minutes, I'm not able to show you too many examples or examples like this one here, because of the fact that ahead of time compilation always takes a lot more time than the just-in-time compilation, the compilation for the JVM. So this is our Hello World example. The first thing we have to do is we have to compile it to bytecode, as you saw on the diagram. And then there is the native image utility to, at the end, compile it to a native image. And then we can run it, because it's just a native executable, like any other command on our operating system. So let's do that. The compilation only takes a few seconds. You can see the native image compilation takes some more time, and it also consumes a lot of memory. So yeah, if you don't run it in a jump box or something like that, you really need a powerful computer to run those, if you have a more advanced application, to compile it to a native image. I think it takes around 1 second, 1 minute to compile it. And one problem you can, I think, directly see with that approach is that really it hinders developer productivity. So if you want to test something out and you have to run it or compile it ahead of time, create a native image, yeah, you can do a lot of coffee breaks, but at the end it's like you're not productive in any way, and for sure there are ways to in a way mitigate these, which will we also see later. You can see now it works. Just can run the native executable, and we have the same output of that native image. Let's have a look at the trade-offs between our Java virtual machine and native image. You can see the startup, or you can later see the startup time is really improved. So it only takes, instead of seconds, several milliseconds. The memory footprint is optimized, but the latency and the throughput is not that high currently as with the JVM, but yeah, Oracle and others that are contributing it, making a lot of improvements regarding the latency and the throughput, and also the maturity. But a huge problem that probably will in the near future never be mitigated is really the build time. So it takes a lot of time. So yeah, several minutes to build a more complex application, or even yeah, hours. And another trade-off is that native image compilation is not aware of dynamic elements of your Java code. And this means if you are using, for example, reflection or resource loading or dynamic proxies, and you just compile your application, you will run into null pointer exceptions, for example, because yeah, the ahead of time compilation is not aware of the stuff you're running dynamically, like, for example, executing a class with a reflection. And yeah, to solve this, let's have a look how that's possible. So at the end, it's like you can do this via so-called native hints. So you provide the information regarding those dynamic language features, how you're using them, for example, calling a specific function or a class, and to the native image tool, and then it knows how to compile it. This also means that at the end, you have to know beforehand which or how you use those dynamic features. Otherwise, it will just not work. Or you have to provide a lot of hints. And to do that, because of, so I have examples for every of those different dynamic features, but let's focus on one because of the time. And that's really a basic reflection example here. So if we just make it a little bit bigger, you can see it's using as an endpoint the class name, the method name you want to we want to execute, and some input, and then with class for name, it gets a method and invokes it. And here you can see the different methods we want to have, so string reverser and string capitalizer. And yeah, if we just compile it and run it with Java on the JVM, it just works. At the end, it's also really fast. If we would do the same with our native image ahead of time compilation and run it, it will run into class not found exception, because it's not aware of the dynamic features. I said because of the time it will not run it now, but yeah, you just have to trust me that it is like that. And what we want to do now is at the end provide those native hints. And GraalVM is providing a tool. So with a agent lib of Java, it's possible to, in a way, if you run your application with those dynamic features on a JVM, it can create those hints, and then you run the ahead of time compilation with those hints, and then the classes will be included and packaged in a native image, and you can run it, and it works for those hints that you provided. We'll do that for now. For that, we will first go to our GraalVM JDK here. Then we create the folder where those native hints will be provided. So that's the default one, but you can also specify it. And then using the Java agent lib here with the output directory, and in this case, the arguments I want to provide. So like where I run it with a JVM, it runs on a JVM with that, and then it generates for me on the JVM, this is also why it's so fast, those hints. We can have a look at them. So you can see at the end it's just what's the name of the class, what are the methods I want to use, and that's it. And those will be now provided to my native image, or it's aware of that folder if I provide it, and uses those hints to include those classes and methods. Also, you can see I have the no fallback option here, because by default what it does, if it's not able to compile it with as a GraalVM native image, it will fall back to JDK, and therefore you're not able to see whether it worked or not. You will just then see based on, for example, the how you're packaging it, etc., that there's a jar and there's no native image, for example. This will also take some time to compile it. And you can also see in the meantime, so for things like, for example, assessing resources on the class path, to get them on the class path, there is a special command for the resource access in a way. Where is it? Here you can use the include resources. And there's another thing called class initialization, because by default, ahead of time, or there's you can have the choice between doing a class initialization at build time or at runtime, and that's something, for example, the Spring team doesn't recommend to initialize classes at build time, because it, for example, also initializes maybe loggers or stuff that's into your class, and therefore then that will your application can run into problems. That stuff is initialized at runtime or at build time, and then should be initialized or created at runtime. So that's also something GraalVM provides as an option to define which of your classes are in a way built at build time or created at initialized at build time, and which on runtime. You can do that also with this functionality. And regarding the example before, we can see it was able to, in a way, create our native image. You can also see that it consumed 3 GB of memory resources, which is, I'd say, a lot for such an easy example. And but we can see with those hints now the application works, because we provided the dynamic information to it. And this is, at the end, what you can do with all the dynamic features, but as that, you have to know about them. So let's always keep that in mind. And maybe if you're heavily using dynamic features, GraalVM or native images is not a solution for you. Okay, so we saw a lot about GraalVM and how to use the native image tool. Let's have a look at Spring, because this is what we're trying to do, is run a Spring Boot application on a serverless runtime and get those benefits of fast startup times and resource reduction. And with Spring Boot 3, the Spring team So colleagues like, for example, Moritz here, sitting here, and he will also do a talk tomorrow. So maybe if you will have some more advanced questions, join the talk tomorrow. Added support for Spring Boot 3 with GraalVM to really get those benefits out of the native image, so fast startup times and a reduced memory consumption. And for that, they really use closed world assumption, because at the end, it's like, Spring Boot is a really dynamic language. And the approach is really like that they are limiting, in a way, how Spring Boot behaves or functionality that's not available on as a native image. Like, for example, you are not able to change the application context in a way at runtime via, for example, profile annotations, or also specific configurations that change the context. And it's also not possible to, in a way, manipulate the bytecode, and Java agents are also not supported. So it's really like, think about whether it's really valuable to you, and then see whether, or how you, in a way, have to modify your application that it really works on a native image, or as a native image. To get started, it's really easy, because at the end, it's supported out of the box with Spring Boot 3. Just go to start.spring.io, select Spring Boot 3. Whatever is available. So currently it's 3.1. And the patch release. And then Java version 17. So even if you can see this here, maybe if you select 8, which is available, and you do a generate or explore, it's still switch to 17, because that's the minimum version for Spring Boot. So minimum version of Spring Boot 3 is 17. And also keep in mind that support for 2.7 will not available anymore after November, if you don't have a commercial support from, for example, VMware. And so with Spring Boot, you have two options to then at the end build your native image for serverless. And the first one is via cloud native build packs, which I showed you before. So there are build packs available also in the open source Paketo repository from us, where you can build your native image instead of your application for the JVM. And there's also the GraalVM native image Maven plugin, which you can use with, as you can see, the native compile command, but you have to provide the profile native for that. Also for the build image, you have to define the profile native, and then it will use ahead of time compilation and build your application. Let's now see how our application behaves as a native image. And for that, I already showed you what you have to define, so there's nothing special. It's just like Spring Boot Starter version 3, then Java version 17, and I also have the native Maven plugin added. And with that, I have all the functionality to create a native image out of Spring Boot. To do that, let's run. Go into the example and run the Maven native compile command with that pnative or native profile. So this will compile our application. As always, with ahead of time compilation, it will take some time. And then we can run it as a native image in our environment here. The same is, as already mentioned, then possible as a container image. I will not show you this today because it takes also some time to build that image. But at the end, it's doing the same as before. What we will do now is I already have prepared such an image, and I can hopefully just use this one and run it on our serverless runtime, so Knative, as soon as this is ready here. Unfortunately not, but it's available. So all the source code and also the instructions are available in a Git repository. I can show you that later, and there you can have a look at it. No, it's created by me for workshops. So yeah, so at the next conference, if I'm doing a workshop there, so for example, we are World Developers Conference, I will be there and do a talk and a workshop. And if you're also there and you want to do it live without the hassle of running the commands yourself, you can just join my workshop and then you can give it a try. So in the meantime, I can also show it because it takes some time. So if you go to my GitHub account, and so I will edit here as a pinned one, but it's if you go to repositories, it's going serverless workshop. So that's the URL, and there is workshop. There are all the samples that I use, so also the GraalVM ones, and those instructions, they are in the workshop content folder. So there are the exercises, and then you can jump to it, and it's a markdown. So. Okay, so let's see. And it's also, so I will show you this later, also in a slide. It's like, this is the reason why it really makes sense, if you want to build native images and get the benefit out of them, that you delegate this building of a native image to your CI/CD system, so that you don't do it on your laptop, because it just takes a lot of time and consuming a lot of resources. And then on the other hand, it's also possible in some situations, for example, there is a property that you can run ahead of time compilation without the native image building on your local laptop, to also, in a way, for example, run some tests, etc., where it's necessary. But in most of the cases, the idea is not to run that on your computer, because that is, as you saw, it's, I think if I would have built that for the JVM, it would be 1 minute or something like that, and it's nearly 4 minutes for that really simple Hello World application. But as you can see, if I now run it, it starts within 100 or 200 milliseconds instead of 4 seconds. So it's a huge improvement regarding the startup time. Without, in this case, because the basic example doesn't use any dynamic features, it just works with compiling it. And then I can also for sure run my curl, and yeah, so it behaves like it should be. And if we now go back, so we were able to, at the end, get the benefits by creating really easily, with that nice integration, the Spring Team build out of our Spring Boot application. And we can also, for example, provide those custom hints that we saw for the dynamic features with the Spring Boot. And for that, we have a so-called runtime hints registrar interface, which you have implement. And then via code or grammatically really can provide the hints to Spring for the dynamic use or the use of dynamic functionality, as you can see here, also for those different types. If you have classes that need binding, for example, JSON serialization, we have a special annotation that you just have to add. But for example, for REST controllers, etc., that support is out of the box available. So you only have to do it if you're using, for example, directly a web client or REST template. Because of the time and the respect of the other speaker, I don't want to show you how that's really done in the code, but you saw it. It's just like implementing that interface. You have to create an import annotation on your class, and with that, you can provide all the hints. One important thing there is that really the Spring team recommends not to use build time initialization of your classes because of those aspects that I mentioned. That could be that you, for example, initialize a logger at build time instead of runtime, which can lead into problems. I already also mentioned that you shouldn't create a native image too often on your own computer, because at the end it's really not good for the developer productivity. So instead, delegate it to a CI/CD system. And here's also the configuration you can set if you want to run ahead of time compilation on your local computer, for example, for tests or something like that. And before I go to one more thing, what I want to show you is also the Knative service for a second, so how it behaves, because it's about serverless. And I pre-created an image for that, which I will now run on Knative, so the same as with the JVM version. You can see also how fast it was created or available because of the fact that the application is just there, and then also the readiness probe responds a lot faster. I can for sure just curl the application, and I can also see here the benefits like the startup time. As already showed you before, also my Kubernetes cluster, it's 140 milliseconds instead of 4 seconds. And if I run the scaling of my application here with the hey command, you can also see as soon as Knative is aware of all that demand, you can see that the application is really starting really fast because of that native compilation. And with that, for sure, you mitigate it in a way that timeout problems. And the last thing we want to have a look at is about the resource consumption. You can see instead of, I think it was 200 to 300 megabyte, it's only 37 megabyte because it doesn't include the JVM and only those classes and dependencies that are required to run the application, and also the CPU resources are half the number of the JVM version. The last thing I want to show you is GraalVM native images are a nice way to, in a way, get those benefits for your serverless runtime. There's one more thing, and it's called JVM Checkpoint Restore, where the Spring team is also working on providing. And Azure, for example, which are also here, are currently contributing to the JVM or JDK. And the idea is that you create a running snapshot of the application, the warm up application, and then you can restore it and get not the same but similar results regarding the startup time. For sure, at the end, it doesn't help you with the memory consumption, but really the startup time is reduced in a way the same way, and you can still use the dynamic features because it's just running on the JVM. This checkpoint restore functionality, it was just added with the latest milestone release of Spring Framework 6.1. And therefore, hopefully in one of the next Spring Boot releases, it will be also available for you to use. And that's it for me. So thank you very much. I hope you enjoyed my session, learned something, and I really recommend to go to Moritz tomorrow, because he probably will add more information, better information. And go to his talk and learn more about it. Thank you very much.